This is the first in the series of the in-depth ones where we're really going to look at models and model catalogs around how do we actually track the models and what goes into them and what describes a model, what makes up a model. And we're actually going to go through and hands-on import a few models and create a new model and some things like that to show you how all those pieces work and how they end up getting represented within our system in the long run as well. So we're going to do a few slides up front. All of these classes, I want them to be very interactive, very hands-on, actually using the product as opposed to just showing you a bunch of slideware. So these will be live demos and walking through all these examples. I'm going to be doing it live. So if I make a typo or something and there's an error, we'll do it again, but bear with me on that kind of thing. This isn't a recorded demo. This is running live. So, and with that too, I also mentioned I'm actually at 10,000 feet off grid. Working through a satellite connection. So if there's a glitch in it, it should come back. Generally, it's been very, very reliable, but you never know on these situations with bandwidth and such like that. So bear with me if there's any problems with that, and I apologize up front if there is. So with that, I do want to mention the next sessions, and I'll be calling out some items in there. The next one will actually be runtimes in your model, where today we're just going to do a really simple echo dummy model to show how we represent models. But next session, we're going to go in how do you actually build a real model and how do you run it within our system? How is it represented? And that kind of thing. So we're going to go in depth around those on that next one. And then we'll be doing actually designing the model life cycles. You'll see last session, you saw one that we actually presented. We're gonna actually dive deep and build a new one from scratch that represents more of a real world use case and how we put that together and deploy it within our system. And finally, we'll finish out with integrating BI tools and specifically Tableau with our system to both represent test data and metrics about how models are doing and also how the business is doing with the models. So those should be great as well, and I encourage you to attend those as well. So with that, I'm going to just briefly bring this slide up. It's a review from last time to specifically talk about the pieces we will be talking about today. Today, primarily, our focus is around Model Manage, which is our model catalog that stores all the information about the models. It does that through utilization of both Mongo for storing the metadata, which we'll examine more in detail as well today, about how we describe all the parts of the model. And then, of course, there's the actual assets, and they're going to actually, we don't have here, but they're going to be stored in either Git. We also have an S3 instance and specific mini IO that we'll be using today, but it can be any S3 that's opaque to us. So anything that's S3 compliant for storing larger files and larger attachments. And we'll be doing some examples of bringing those in today to see how they're actually stored and incorporated within the system. So that will be our focus today, although we will be also using Jupyter once again. We're actually going to develop a new model in Jupyter rather than just importing one like last time. And of course, we'll be running them on the engine and using the life cycle because that's the value of the product on that kind of. So those are kind of the pieces we'll be focusing around today. I know nobody can read this slide. Don't worry, it's not intended that you can read it. It's a bit of an eye chart for sure. But the idea is models in our system are not just a Python file or some even just a weights file or a Docker container or YASM-C just as the full abstraction of the model. That doesn't provide us the insight necessary to really understand models within the business. So we've come up with quite a large data structure. Matter of fact, this is only part of it, but I want to give you some examples. We're going to dive into a few key areas today in our data model to help understand what we put into this and how flexible we are in defining what a model is to us. A model in business to us, absolutely everybody talks about AI models today and trained and all that kind of things on that. That's a small portion of the models that are actually in business. Often you see simple decision tables and things like that that have just simple if then else kind of architecture behind them. Those are still models. They're still making decisions about routing business traffic or whether people get loans or not or all kinds of things. And we want to be able to manage those kind of legacy traditional models within our system as well as R models and that what comes with that, and Python. And then even with Python, you don't even have just the Python source code, as you'll see today. You have attachments that go with it, test data, all kinds of different things that need to be represented. So we've come up with a pretty sophisticated data model for being able to describe all of these different types of models, but in a consistent pattern, so we can still capture consistent information across these diverse sets of models. So one of the ways we do that is we actually have this concept of model assets, and that's what we'll be looking at a lot today, because those are probably the most tangible portion of what describes a model. You have a series of different kind of pieces, like I just described earlier there, that really make up the totality of a model. So, as I mentioned, weights files are a great example, but, just weight files alone, if you just have that, doesn't really give you the depth of knowledge about that model. So, we want the original source that went with that, or maybe the source that uses the weight files. We want to know what the training data was that actually trained and went into that weights file, so it's reproducible. In fact, ideally, as we showed in the last class, we want to actually do that training ourselves in a controlled environment, so we know that really that training data was used to generate that weights file that's associated with the model, rather than an assumption of somebody manually filling in this information. Now, again, we can represent both because our data model is extremely flexible, where if you just want to give us a weights file and that's the whole model, we can do that. But, we want to be able to take it so much further. So, when we talk about assets as we come through, you're going to see that we talk about assets in two ways, both like where they are located or how we access them. So we're going to be talking about today some assets that are located in S3. We're going to be talking about some assets that are located in Git. We're going to be talking about different things. So there's the kind of asset when we call to it. So example, a source code asset. It's typically located in a repository such as Git. But there's also this concept of a role that is associated with a file as well. So we're going to see where we go through, and we have model source code is one example, and matter of fact, primary model source code and specific that we're going to do on that. But you may have code, or you may have example data that's used for reference, or you may have all kinds of different things like that we want to describe. So we have the type of a source code asset, but then underneath that we have the base asset contains this thing we call asset role, which describes its actual function within the model, so that we can have it. So like a license file is a license file. We want to know that because maybe this model can only be used in certain ways, and we want to tag those things and be able to access and filter and all that kind of things as well. So we have that. Another example of another kind of asset we have is an external file asset. It's located in something like S3 or HDFS, a large blob store kind of file. We wouldn't want to pull those into our database and replicate those. I mean, I've dealt with models where weights files are 4 or 6 gigabyte in size when you get to things like image recognition and stuff. We need a good secure store for those that is globally referenceable. As I said, today we'll be showing that utilizing Mini.io and S3 in specific. But we work with, of course, Amazon, AWS, and Azure Blob Store, any of those kinds of standard things on that kind of things. But additionally, there's this concept of, okay, well, what does that file represent? That's what we refer to as asset role when we go through these things and talk about them. Where they're going to have like it's going to be weights file, or it's a training data set, or a test data set, or things like that. So we have that multi-layer kind of ability of layering these different assets together, which make up the story about what the model is. And that's what we're getting at the core of here with the model catalog, is being able to identify all of those individual pieces that make up the model and govern and track them throughout the system. And be able to reassemble the model when we get it onto the runtime. We know what pieces need to go where based on what they're doing and their roles and things like that. Like if we're installing a model, we don't need to install the test data for that model. We want it as a reference, but when we go to actually do that, but we sure want to grab the source code and the model source code and the weights files and install those in their proper locations at runtime. So we have that kind of packaging information about what the model actually has, as well as all of the other pieces are there for governance and reproducibility and things like that as well. Aspect we're going to look at today in specific is a little bit about like the model history, so to speak, and how we describe that. So, we have the concept, for instance, of a deployed model that is stored within our system. So our base model is what we refer to as our stored model. That's a live kind of view of up to the minute of all the assets, all of the items that are there, and all the different pieces that kind of sit there that make up that model. Obviously, over time, those could change. So, people can do all kinds of things to that. So when we actually go for governance and reproducibility and stuff, when people actually go and deploy a model somewhere, we create an instance of what we call a deployed model, which is a snapshot of instance in time. And we'll look at more details of what's in that. But we have everything like the Git commit IDs and all that kind of stuff. So we can go back and get the original resources, assuming Git stays around, which would be a good company practice, of all of the different items of what they were in that history. Now, obviously, we're constrained a little bit around things like if it's an S3 pointer, we assume that the S3 stays around as it is, and that you would uniquely revision it in a more immutable kind of fashion, which would be best standard practices. So that you rotate the file name or the bucket or something over time, so that we reference that. We're not trying to be a new versioned file system out there. There's plenty of things that do that. So we rely on those capabilities of those kinds of systems to do that. But we will have a snapshot of that model at the time it was deployed, so we know the exact state when that model was deployed. But likewise, we also need to know kind of when a model is actually considered deployable. So we have that concept of the deployable model. You could almost think of that as like a model version. Without going into the numbers, it's saying that, yeah, this model is complete and can now be executed. And that it can either be deployed onto a runtime engine, which will, or it's ready for batch jobs or testing or other kinds of things to occur with the model and things like that. So it means that all of the assets you see there are actually in the ready state, and it's ready to go. And we will snapshot that out at that point in time, and again, capture all that metadata about what it is at that point in time. And that's now considered, in essence, a version. So a little more flexible than just a version number rather than that kind of things. We can absolutely tag it with a version number if you want to do that, or we could publish that at that time into an artifact repository to then be referenced from there. But the idea is we know all about that model, all of its metadata, and all the different things that's going on at that exact moment in history. And we'll keep that there. So when you run a job against that, you run a job rather than against the stored model, which is the live up to the second action. You run it against one of these deployable models, so we can always get back to the original data about that model and that specific job, and we capture that kind of mission. So we'll examine a little bit how that works today too, as we add a model and run it through its paces, so to speak, on that. So as I mentioned, I want to keep the slide wear down to a minimum. So instead of just doing that, we're going to actually go hands-on here. We're going to show you a few different methodologies of A, how do we get the models into the system and into the model catalog? And B, then what does it look like once we do that? So we can understand that, and we'll even actually go down that. So we're going to start out by actually importing a model from the existing Git repository, and we're going to pull it from public GitHub, just as an example, to show you how that all works. And then we're going to walk through that model and actually examine those individual resources to make the previous slides I show you a little more concrete and hopefully a little more understandable through that process. Then we're actually going to go through instead and take a different approach, which is we're going to create a brand new model, albeit a very simple one to make it easy on us here. But we're going to create a new model in a Jupyter notebook and show how we can delineate between Scratch notebook code and all of that kind of things, and also import the actual model code and some attachments into the ModelOps system, and we'll view that through the ModelOp catalog and actually run it through some tests and things like that as well within the system, so we can see how that works. Then finally, we'll dive a little deep for those who want to really understand the idea behind the model catalog. We're going to go and actually use Swagger in specific. We have Swagger UI installed in our product to actually go and query the model catalog directly and look at some of these and how we can do different filtering and sorting and things like that, so that you can use the model catalog for your own purposes. Because yes, we have our great UI with the ModelOp Center, that provides you all kinds of access to a bunch of different information, but we're actually storing more than could possibly be exposed in the UI. So when it comes down to your custom business features and metrics and things like that, everything we do in our UI is through the same RESTful interface we'll be looking at today. So you can invent your own queries, invent your own methodologies to incorporate that model catalog information into your business needs as well, as to how you do that on that kind of thing. So just the generic thank you slide, because we're going to switch to the real code here. So give me just 1 second to drop out of this, and we're going to go over to our product instead. And I said the first part that we're going to do. So as we saw last week, we're going to use our ModelOp Center UI to start out with here. We're going to do that first importation of an existing product from Git. And then we'll do a new one in Jupyter again to just show you the kind of different worlds that we can do there. So as a reminder, we have our model catalog in here. We have a bunch of existing models. Models can come from a variety of sources. So we have ones that were already imported from an existing Git in the background. We have ones imported from Dataiku, et cetera. So we have all different kinds of things. But eventually, you're going to want to get more models into the system. So how do we actually do that? Well, we're going to start out with a real simple one where we're going to grab this. And let me grab that real quick here. So we're going to go live to just github.com here, and we're going to grab one. We have a demo model out there. Let me grab that real quick. Actually, I'm going to jump to this real quick and copy the clone URL. Will actually be easier than trying to type it by hand, because I'm afraid I'm going to make a typo otherwise. So as I said, I like to do this stuff live. So we'll just go out, prove it's really out there here and that kind of thing. So we'll grab that. And it's quicker if I just grab the clone URL from that. So we will grab the URL right out of the GitHub here, and we will paste it into our importation. And we can choose the branch if we want a specific branch as well on that kind of thing to track on that kind of thing. So we're going to go ahead and import, and this will just take a second because I actually do have a rather large pickle file associated with this as well. So it's going out and actually cloning the repo, capturing all the metadata about that, looking at all the individual files that came down, sorting them into their different types, and creating that representation of the model within our system on that kind of things, and making its best guesses as it can about the individual different kinds of files that it should be doing. So set this live. We'll take just a second here. There we go. So now it's imported that model. So if you go out and look at the model out in Git, we can see it actually had license files, readmes, Python files, series of assets. Excuse me. In specific, we can see, for instance, it has both a model file and a pickle file because it's an XGBoost model. So, it has a bunch of different things it needs in order to execute successfully. So what we've done in the background is, first of all, we grab some metadata. I'll explain these in a minute. The model was actually tagged with our features, so we're able to actually grab the individual functions we should be calling. You can also use default names. We'll talk more in detail about what that actually means in our next session around runtimes and what different functions and tags and et cetera are available. So we'll deep dive on that next week to really explain how those work and what's there. But you can see, it found the individual model sources and was able to bring those in. It also captured some of that metadata about the repository that pulled in from, so we can see that where it actually cached a local copy, because we're going to keep that in sync in the background. Before we do anything, we're going to be doing pushes and pulls and et cetera from the remote repository to make sure everything's in sync locally with the local cache. And then we also know the remote that was actually there, so we have all that information about the Git asset in that case, and that's one of those code assets we were talking about on that kind of things. But you'll also see we have a variety of different, we're just referring to them generically as attachments here, but we have them in different roles. So we have that pickle file that actually came in that we actually know, and we have some files that we weren't so sure about. We have a generic model file, we have a license file. We could modify that to indicate that it is the actual thing. So we grab the README as well. So we have all those different assets with all those different roles actually describing the model itself. So we have that kind
Hey,
of things.
Jim.
We don't.
Hey,
Yes.
Jim. It's Linda. There is a question. Does ModelOp Center rely on a specific repo structure in Git?
No, in Git, it just pulls in. So when, for instance, with the sources, when we capture the metadata, I don't think, yeah, it doesn't show it on here, but we do actually capture the original path of the item on that, and we will restore that path when we reconstruct the model. So for instance, if you look at here as an example, let's see, where's the begin function in here? I'm not sure if you can see this because it's kind of small, but yeah, no, it's not gonna things like that be as visible. But for instance, when we look at this, assets is that was defined by the model. It could just as likely be under weights files or anything else. What we will do is capture the original relative path underneath that directory, and when we restore the asset, when we reconstruct it, we will actually place it into that same subpath. So if your code is written to read it in that structure, it'll take it. So you can do anything you want, as many layers deep as you want. We're gonna capture and restore that information. Okay, good question on there. So we stay as because basically because we're actually kind of platform agnostic. Like anything you can do in Python. So if you have a submodule, for an example, we'll import it, and if you have your init.py, you'll be able to import it just as is, and things like that. So we respect the original structure of the problem.
Hey, Jim, there is another question.
Yeah, sure.
How does the data model get populated that includes all the very granular metadata of that model?
Well, as I said, it depends on the structure. When we get to the Jupyter plugin, we'll see how we can specify that more. When we go to some we make inferences as best as we can. But as you can see here, we can go in and tweak it up later if we need specific items. But generally, like if it's .py or .py3, we know it's a source file. If it's a pickle, we know it's a pickle file and things like that. That doesn't mean after you do this import, that's why you immediately get to it. You might need to tweak a couple things one time. But once you do that one time, that metadata is stored in Mongo and references the Git information, so you would never need to do that again. When we do the Jupyter example in a little bit, you'll see how we can specify that up front. So, okay. So that's basically an example of
question. Thanks.
Yeah. So that kind of shows how you can bring it in from Git. And with that, I do want to jump into the Jupyter one because that may help clarify some of that as well, where we're going to create one from scratch. So we're going to use my local Jupyter instance here. Why am I going to HPS? That would be the problem. Jupyter. Let me bring up that. And as we showed last time, we have our model functions installed within Jupyter, and that's how we're going to be actually interacting with the system today. So we're going to go back and we're going to create a brand new model from scratch. Unlike last time where we downloaded one from our catalog, we're going to actually bring it in and create a new one. So we're going to make a ridiculously simple one this time. As I said, I highly suggest attending the next class where we're going to make real models that do stuff and real scoring. But in the interest of brevity, we're going to create a real simple model today. Ridiculously simple. And I'm going to tag this one as a scoring function. And we're going to make a real simple one here. It's going to be a real complex model here. Simple echo. So we're just going to basically go ahead and send back whatever they receive. And we're also going to make a metrics function that does scoring. And we're just going to do that. It also takes a datum, and that datum can be anything. We use pandas or things like that as well. And we're going to send back a dictionary of our scoring results. Now, we're going to just do, as said, for the interest and brevity of time today, we're just going to do fake ones here. But you can send back any name value pairs, and if you send back specific ones like an ROC or some things like that, we will actually know how to draw those, and we do have a list of those for some standard things. That's what's typing and talking at the same time can be difficult. So, okay, there's our real simple model, ridiculously simple. We can actually go in and we'll verify all looks good. Sure enough, it loads. Now, in another cell, we just kind of want to have we just want to exercise it a little bit. That's the power of notebooks. So we're just going to call one of our functions here real quick. Just going to print the value out. And then we're going to do the same thing with our metrics function. Whoa, hit the wrong button there. Proves I'm doing this live. Okay, so maybe we're just playing around with the model, and we run it, we cast it. Now, that's the cool thing about notebooks is you want to be able to interactively play with it and things like that. So we've got our real model code up here, and then we have our play around. Maybe we have another cell that just plays with some data and stuff that aren't really model assets, so to speak. And we want to be able to differentiate between those two. So now we have our spectacular model here ready for things. We're going to go ahead and actually onboard that model. So we're going to go ahead and bring up our plugin, and we're going to say, hey, which cells do we actually want to associate with the model? Now we're going to grab the actual model code in this case. Now, if we had some test code, we could add that as well. I wouldn't call this test code. This is just playing around with the model. So we're not going to put that into our model. We're only going to put this one cell in there, and we're going to go through, and it's just going to ask us for what a new model is. My new echo, sure. A model for demo. Okay, so it's going to ask us a few questions and walk it through. And then we're actually going to be able to say, like, hey, do we want to associate this with a remote repository? We're just going to go with a local one on master for now. We could also even not associate it with a repository, but then you wouldn't get versioning information beyond, at the source code level. So we're going to leave that in there. And then it's going to ask us just to give us a name for the file. So we're just going to call it new echo.py3. And we'll inherit the basically the Git from the master one. So let's see, what did I do wrong here? Oh, whoop, no, .py3. And then we're going to say that this is the primary model source on that kind of thing. So I'm going to go add that in, and then we could even, let's say we had some test data. I'm just going to grab a bogus file here of a JSON file, but we can add in attachments at this time too if we had some additional items that we wanted to do. And when we actually create this, what it's going to do is it's actually going to, for us in this case, it's going to move that out to an S3 bucket and make it globally referenceable and upload it and store it there and get us a new S3 URL. So now we've got it. We've got the things like that. We're going to go ahead and actually submit that model. And now that's actually created within the system. So we're going to go out here, and now if we go back to our models, we're going to see where it's now in the model catalog. We've got that my new echo in there. We've got the simple metadata that we put in here. We have that cell appears as an individual source file, and in fact, we have the metadata information about the commits and things like that, so we know where it's being tracked within Git. In this case, we don't have a remote, just for the interest of time, but we've got that, as well as we've got the information about the attachments. We got that little JSON file that we actually stuck in there as well, that you can see it was actually stored now in an S3 bucket out there in Mini.io. So now it's been a new name, but we maintain the original name, but we actually map it to a new unique name that's guaranteed unique across all of that, just in case they have duplicate file names, and is stored associated with the model. In this case, it's underneath the UUID of the model, under that kind of things, underneath a user-specific directory associated with Mini.io, and all that user stuff is done by OAuth too. So we have that, as well as we capture, like we saw last time, we capture all the platform information. The plugin automatically went and queried the Python kernel with all that information about the individual model. So now you can see how that new model was actually registered within our system. We have that full information there. So right now, I'm going to bring up the Swagger UI here just real quick. Right now, you can see we have this full Swagger interface. We're going to use jump back and forth between Jupyter and this for a little bit to show how it works. So, we have the full stored model entity that's out there, and that's where our individual one is. You see we have full get, put, pass, patch, all of that kind of things to actually be able to interact with those models. And we can search by name, search by types, all of those kinds of things. So we have a pretty extensive set of APIs you can use to do that. But what I want to point out is we're going to quickly look at the deployable to get where things. So like if we were to execute this right now, I've purposely wiped out all of the backend database before we started this so we can see. So we can see, in fact, that right now we get no deployable models things. So, we don't have any that are considered finished. So how do we progress that along? Well, basically, we could make some more changes. Test result, let's say 2. Go. All right. Okay, my Jupyter is locked up for some reason. Let me just refresh that real quick here. Let me go back to my notebook. Let me go back to my notebook. Something's screwy is going on here with my Jupyter there and that kind of thing. Okay. My notebook here. See if it lets me type again. There we go. Something more. Okay, so basically, we could continue to update the model. Oh, I got the wrong button there. So okay, let me just jump back out of here. Browser, is she there? We want to actually create a deployable model. For instance, we can finally kind of say that the model is ready for execution. So one of the things we wanted to do was basically let me jump over to our life cycle view here real quick. From last time, we have the ability to basically specify a path we want all models to go through when they're submitted on that kind of thing. So we have that model refresh where we talked about where we're going to run it through its tests and run it through the metrics and then seek approval on that kind of thing. So we have our model. It's actually ready to go. We can, through the plugin or through here, we can go ahead and actually submit the model, and we'll see it's actually going out, it's running the unit tests, and do that. So now that new model we just did, we just verified that it does actually pass those tests and can run successfully, and did send us the information over here, so we can go to the Jira board like last time here, and we can see the information about our brand new model that we just created in and review its individual tests on that. Come on, everything's running a little slow on me here. So if we go to our project, we can see that we actually did receive the information about our brand new model that we just things, and we can even jump over to the test results and renew that model. And we can see again, we just did some simple ones. So our test results are pretty generic. It's just the foo and the bar test results. So it doesn't. Yeah, we don't translate those to anything pretty, but we can see the get information that it was a new model that we actually added, and we can see how it's been imported into our system, that cell as that thing. So, we're able to actually kind of run through a true model life cycle in essence on that. But the side effect of what happened when we did that, because we actually submitted the model, is if we go back to our Swagger interface, we can see we now have that snapshot. That's what we talk about when we create a deployable model. It's basically a model version. It's similar to like doing a push in Git. You do all your commits, you kind of work on your item for a periods of time, your cache locally, but you're not saying it's done. You either submit a pull request or you do your push, and then from that, all those changes are captured together, and we capture that item. So we have the stored model, and I know it's a bit of an eye chart again on that, and I apologize for that, but we do have the concept of these assets, and we have all of the Git. There it is. So for instance, we have all the Git IDs that were actually captured as part of that process. So we know the changes that were made. We know the individual IDs of the latest versions of those files. So we can go back to Git being the authoritative resource for information about that and be able to capture that no matter what additional changes they make to the model down the road, or even if they, the items on that. So, we have that kind of the information available. And that's why we capture that as part of the deployable model. So we have that true governance of making sure we know the exact code, who did what, when, et cetera, on that kind of things when all of these items occur. Because what we want to do is, so now we're waiting on our approval. So we're going to go over and just go ahead and actually mark this ticket as done, which will then move the process along and actually deploy that model. So that model now is actually deployed onto one of our runtimes as part of that, all something we just created right now. And we can see that it's actually running out on this engine too. So when we go to that, and we're going to talk more about this later, but you can see we didn't write any transport code. That's one of the advantages of our runtime. We'll jump into this in depth in the next system too, but we already set up this engine to listen on a RESTful endpoint. So just that code is now going to respond on REST, obviously just back with whatever we send it, that kind of thing. So we have that kind of ability, and we're going to do a deep dive on all that kind of stuff and the different bindings, et cetera, you can do in the next masterclass as well. But we can go and look at the live view of that actual model, so we can see the journey it took. We have information. We know the exact version of that deployable model that we just created. So we have the way to actually go through and get that full end-to-end governance of that model, get back to its source, know what data was trained. We didn't train this one. That's why we can see it didn't follow a training path, but we can get that kind of information, and we have those test scores before it was moved out and who approved it and all that kind of things. And that gets to the larger utilization of the model catalog to then provide that kind of history and data and everything in the background that ties it all together to make sure you know where your models are, where they made it through the business, who's reviewed them, how they got there, here's all the reports associated with it, all the things that really need to happen with a model actually in the in a business to really get out there and provide that kind of story about it. So with that, I did today want to make sure I left about 5 minutes here at the end to go through any questions anyone might have on what you've seen today.
Yes.
Have any, Linda?
Yeah, there are a couple coming in. The first one is there a way to track who made the changes to the model through ModelOp Center?
Yes, correct. We would the level you're looking at. Individual data fields, we right now do not track complete history of, like, if you were to switch the role of a file or something like that. We do capture the last person who did it, and when we snapshot as a deployable model, that will last forever, so the last touch. But when it comes to things like the source files or things like that, that's where we rely on Git to provide us that full history. Since we have the actual object ID of that point in time, we will have the full history of all changes made to any of those assets readily available.
Good, thank you. There's another one. Where do you tell ModelOp Center which function to expose as the RESTful endpoint for scoring?
Okay, there's two different ways of actually doing it. Show you that. We're going to go into that in depth in the next class, but I can quickly show you right now. There's get the model we just worked on to make it directly relevant. I'll just grab another one. It doesn't really matter. I'll just grab that one. It's quicker. So you can see here, I could choose them manually right here where I can edit the functions. So for instance, our score and edit functions. But a much simpler way of doing it, and what we provide for, is you can just use that little annotation, that comment on the functions that we should be calling based on that. So we scan for the presence of those comments, and when we see those, we'll automatically populate that information upon either import or update.
Perfect timing. Thank you so much, Jim. Thanks everybody for attending this masterclass. We got another next Monday. You will receive an email with the deck, the recording, the link to the next masterclass. Feel free to forward the invite to your peer, your colleague, your network, and talk to you next Monday. Have a great day to everyone.
Thank you, everyone, for spending the time with me today. I really appreciate it.